Now we have the capability of checking objects that arrive to the inner solar system from far away. And this object looks anomalous to me for a variety of reasons, and all I'm advocating is observing it with all the assets we have in space, on the ground, just to figure it out.
When one of the world's most powerful telescopes, the Keck Observatory in Hawaii, turned its gaze toward the interstellar visitor known as 3I Atlas, astronomers expected a typical comet, but what they saw shattered that idea. Instead of quietly venting gas like most comets do, 3I Atlas suddenly released massive jets of water, while still in a region colder than -330 degrees Fahrenheit. That's physically impossible under normal comet behavior, yet Keck's infrared data confirmed it. At the same time, the European Space Agency and several ground observatories detected nickel-rich emissions, the kind usually seen in engineered alloys, not natural ice or rock. Meanwhile, NASA has stayed silent, withholding high-resolution images captured by the Perseverance rover. The missing data only deepens one unsettling question. If 3I Atlas is truly a comet, why does it contain industrial-grade metals and behave as if something or someone is guiding it? Could this be a rare cosmic fluke, or the first technosignature humanity has ever witnessed? For most of human history, we believed our solar system was isolated, a quiet neighborhood drifting through the galaxy. That changed in 2017, when astronomers spotted something racing across the sky that didn't belong to us. They called it 1 Oumuamua, the first confirmed interstellar object ever detected, a visitor born around another star. 2 years later came 2 Borisov, a more traditional comet carrying chemical fingerprints from a distant sun. Together, they proved a stunning truth. Our solar system isn't alone. Space is full of wanderers passing through, carrying the dust and secrets of other worlds. Now, a third traveler has arrived, and it's rewriting the rules again. Officially named 3I Atlas, this object is the third interstellar visitor ever confirmed by the Minor Planet Center. But from the moment scientists traced its motion, they realized it wasn't like the others. While Oumuamua tumbled erratically and Borisov disintegrated like an icy comet, 3I Atlas moved with eerie stability. It followed a hyperbolic trajectory, a path so open that it will never circle the sun. But its rotation remained steady, almost mechanical. No natural comet behaves like that, especially not one shedding water in the deep freeze of space. Even more surprising, its light didn't flicker randomly. Instruments aboard the Mars Express and Trace Gas Orbiter, 2 spacecraft operated by the European Space Agency, recorded a rhythmic pulse in its brightness, fluctuations repeating every few hours like a cosmic heartbeat. Data analysts first thought it might be simple sunlight bouncing off uneven surfaces, but the pattern was too precise, too consistent, as if the object were transmitting something or responding to observation. Meanwhile, the Keck Observatory and TESS satellite back on Earth tracked the same oscillations from different angles. The alignment was perfect. Whatever 3I Atlas was doing, it was doing it deliberately, or at least predictably. This behavior has forced scientists to revisit a question that has haunted astronomy since the discovery of Oumuamua. What if some interstellar visitors aren't just rocks or ice? What if they are something built? Something designed to travel? A comet that doesn't behave like a comet, a pulse that repeats like a signal, a body stable enough to defy the chaos of interstellar space. One fact remains certain: 3I Atlas isn't from here. And as it drifts closer to the inner solar system, that repeating light continues to flash, steady, deliberate, impossible to ignore. A traveler from beyond the sun, shining in rhythm. Could it really be coincidence? Or are we witnessing the first sign of a reply? When the European Space Agency released the first clear images of 3I Atlas as it passed by Mars, the scientific community held its breath. Taken by Mars Express and the Trace Gas Orbiter, the images showed a faint ball of light floating in the thin Martian atmosphere, distant, hazy, but undeniably present. Within hours, the images had spread across the globe, making headlines from BBC Science Focus to Scientific American. Yet something was missing. From NASA's side, silence reigned. The Perseverance rover, perched on the Martian surface with its high-resolution cameras pointed skyward, had the perfect vantage point to observe the same region of space, but no images appeared. Its light pulsed, its composition changed, and every time someone studied it, it seemed to react, as if it was aware of being watched. Inside the Jet Propulsion Laboratory, several sources confirmed that the raw image data from Mars had been transmitted back to Earth. When asked why it hadn't appeared in NASA's public archives, the short explanation: the agency was in the midst of a federal government shutdown, which had temporarily halted updates to its data portals and communications channels. Such pauses are routine in large organizations, administrative freezes that affect every project, not just one. But the timing couldn't have been more odd. As 3I Atlas entered the inner solar system, the flow of information stopped. While the agency waited to resume operations, independent astronomers began sifting through what little remained. In online forums, users pieced together faint traces from Perseverance's rover camera, long exposure collages that appeared to show a cylindrical object reflecting sunlight across multiple frames. The images were grainy and unclear, but they went viral. Some argued they were artifacts, cosmic rays, or simply camera drift. Others insisted they had captured something real, a glimpse of an interstellar visitor appearing on the Martian horizon. Even professional astronomers disagreed. Keck observations had confirmed 3I Atlas was near Mars's orbit, but its exact distance remained uncertain, allowing speculation to flourish. As the months passed and the shutdown continued, hashtags like #WhereIsTheData began trending across online scientific communities. The debate wasn't about conspiracy theories. It's about curiosity, the discomfort of silence in a field built on open exploration. Perhaps the explanation is just routine bureaucracy. But perhaps the real mystery isn't that NASA has stopped talking. It's what might be waiting when the silence is finally broken. On August 24, 2025, the Keck Observatory in Hawaii conducted a high-resolution spectrographic scan of 3I Atlas, focusing on wavelengths between 3,425 and 5,500 angstroms. What came back stunned the research team. Instead of the usual cocktail of iron and silicate emissions found in every known comet, Keck's data showed something entirely different: an intense, isolated nickel signature with no trace of iron anywhere in the spectrum. At first, analysts thought it might be an instrument glitch or contamination from Earth's atmosphere, but follow-up scans confirmed it. 3I Atlas was releasing nickel vapor in quantities that natural processes simply couldn't explain. Even the European Southern Observatory in Chile, cross-checking with their very large telescope, saw the same emission lines. The pattern was unmistakable, a bright spike where iron should have been silent. In nature, iron and nickel almost always travel together. They form side by side in stars, mix inside asteroids, and appear in meteorites as twin fingerprints of cosmic chemistry. Finding one without the other is like discovering smoke with no fire. Yet 3I Atlas seemed to be made of refined nickel, a metal that on Earth only appears in such purity through industrial processes. The oddity grew deeper when chemists examined how this element could exist in such a state. In laboratories and factories, pure nickel is often produced through the nickel-carbonyl process, a reaction that forms nickel carbonyl, requiring controlled pressure and high temperatures inside sealed systems. It's a method used in metallurgy, not astrophysics. Out in the freezing vacuum of interstellar space, those conditions shouldn't exist at all. Still, some researchers tried to preserve the natural explanation. A few proposed that maybe internal friction or radioactive decay inside the object created a spontaneous core reaction, momentarily melting and refining its metals. But no existing model has ever shown how that could happen inside a comet core colder than -330 degrees Fahrenheit. The math just doesn't work. By early September, the debate had spilled beyond the observatories. Science journals began publishing cautious phrases like anomalous spectral behavior and non-terrestrial metal ratios. But behind closed doors, one quiet question dominated every meeting. How could an interstellar object carry the mark of a metallurgical process? For astronomers trained to see the universe through natural laws, this was a crack in the foundation. A body drifting through the frozen dark was showing the spectral scars of smelting, as if somewhere, long before it reached us, heat and precision once touched its surface. A traveler forged in another furnace, still glowing faintly across the void. So what does it mean when something colder than any foundry in the galaxy bears the fingerprints of one? The deeper scientists looked into 3I Atlas, the stranger it became. When Keck Observatory's instruments mapped its spectral signature, the readings revealed a disturbing pattern. Within a radius of roughly 600 kilometers, the object's emissions were dominated by nickel, the same refined metal seen in earlier scans. But surrounding that metallic heart, spreading out to nearly 840 kilometers, was a faint but unmistakable trace of cyanide, one of the most chemically reactive compounds linked to the origin of life. At first glance, it seemed impossible. Nickel in pure industrial form and cyanide in an organic matrix are never found together in natural cosmic environments. They belong to opposite ends of chemistry, one forged in furnaces, the other born in the delicate chaos of biology. Yet here they were, locked together in the same interstellar traveler. Cyanide has always fascinated astrobiologists. On Earth, it is both a poison and a promise. Billions of years ago, in the planet's primordial oceans, cyanide molecules are thought to have helped form amino acids, the basic building blocks of DNA. NASA's own Origins of Life studies have shown that traces of CN can exist in the dust clouds surrounding newborn stars, acting as seeds for complex organic reactions. But never before had cyanide been detected in tandem with refined metal. The Keck data made the case undeniable. The CN emissions followed a repeating wave around the object's equator, suggesting that the compound wasn't just frozen into the surface, it was being released in timed bursts, almost like venting or respiration. European Space Agency analysts called it the dual-band anomaly, a region where lifelike chemistry and metallurgical precision seem to overlap. When researchers from the University of Arizona reviewed the findings, one of them coined a haunting phrase that stuck: the life machine paradox. It describes something that shouldn't exist, matter that behaves partly like a biological organism and partly like a manufactured device, a body with both organic compounds and engineered alloys. For months, the scientific community wrestled with how to categorize it. Was 3I Atlas a comet corrupted by industrial contamination from another system? Or was it evidence of a far older experiment, a probe carrying the ingredients of life across galaxies? The lines between science and speculation blurred more each day. If 3I Atlas was never built, then why does its chemical blueprint carry the fingerprints of both creation and construction? Why does it hold the formula of two worlds, one born of nature and one designed by intelligence? For months, 3I Atlas drifted through the void like a silent ember, reflecting nothing more than faint sunlight. Then, as it entered the orbit of Mars, something changed. Spectrographs from the Keck Observatory and the Trace Gas Orbiter suddenly registered a massive burst of water vapor erupting from the object's core, a jet so intense it briefly outshone the comet's own coma. No one expected that. At that distance from the Sun, temperatures fall below -330 degrees Fahrenheit, -200 degrees Celsius, far too cold for ice to sublimate or liquid water to exist. In the vacuum of space, even the smallest trace of heat should have been impossible to sustain. However, the data was clear. A concentrated plume of H2O molecules expanding outward at nearly 400 miles per hour, as if something deep inside had come alive. Comets often vent gas when they warm near the Sun, but 3I Atlas wasn't anywhere close enough for that. Its trajectory placed it beyond the frost line, in a zone where solar radiation can't trigger that kind of eruption. The amount of pressure required to expel water under those conditions would demand either an internal heat source or a mechanical release system, both equally unthinkable for a natural body. Researchers at ESA and Caltech began running simulations. None of them could reproduce the event without inserting an artificial energy input. Even then, the thermal model behaved like a heartbeat, a short rhythmic pulse every few hours, perfectly timed with the brightness oscillations previously recorded from Mars. That rhythm drew comparisons to geothermal cycles, reactor cooling loops, even primitive propulsion systems. But no theory fits every variable. The Keck team published a cautious statement calling it a transient internal heating anomaly, while independent physicists online called it what it looked like, an activation. If the water jet were just chemistry, it should have faded quickly. Instead, the emission stabilized into a slow, deliberate mist, circling the object's midsection in a pattern that suggested balance, not decay. It looked less like a comet losing material and more like something regulating itself, releasing pressure, maintaining structure, conserving motion. Across observatories, the same phrase began to appear in internal memos. Self-modulating activity detected. For the first time, scientists were forced to ask whether 3I Atlas was merely reacting to sunlight or responding to something else entirely, because if this wasn't a natural outgassing event, it might mean the object hadn't malfunctioned at all. It might mean it had just woken up. Long before the headlines, before the water jets and metallic signatures, 3I Atlas was already there, hiding in plain sight. When researchers revisited archived observations from NASA's Transiting Exoplanet Survey satellite, TESS, they found something that had gone unnoticed. Between May and June 2025, the satellite had recorded a faint, fast-moving object sweeping across its field of view. The coordinates matched perfectly. It was 3I Atlas. But the early data told a very different story. Back then, the object showed no trace of dust, gas, or coma, none of the hazy halo that defines a comet. Instead, its light curve was sharp and clean, almost identical to the readings of solid stony asteroids. Its reflectivity, or albedo, aligned with 4 other known rocky bodies, suggesting a hard, compact surface. In other words, it wasn't evaporating. It was intact, and it was massive. By comparing its apparent magnitude to distance estimates, astronomers calculated that 3I Atlas measured between 12 and 14 kilometers across, nearly twice the size of the average comet nucleus. That scale placed it among the largest interstellar visitors ever recorded, rivaling even minor planets in our own solar system. But something else in the TESS data stood out, something subtle yet deeply unsettling. Comets always reveal their direction through light. As they near the Sun, solar radiation pushes dust and gas outward, forming a tail that always points away from the light source. But when analysts enhanced the early frames of 3I Atlas, they found the opposite. If that were true, it would mean this object wasn't just a piece of frozen rock, but a machine of some kind, adjusting its chemical makeup to survive. At first, some suggested camera artifacts or background star interference, but those explanations failed once the same asymmetry appeared across multiple exposures. The object's brightness fluctuated, not randomly, but in a pattern, a slow modulation over several hours, as if its surface reflectivity was being tuned. One researcher from MIT's Kavli Institute described it as directional scattering, an effect that can occur if a surface adjusts its reflective properties with rotation or through active control. No one could explain how a natural object could do that. By the time this discovery was cross-checked with Keck and ESA data, one question loomed over the entire investigation. If 3I Atlas was reflecting sunlight, why did the reflection behave like a coded pulse, uneven, targeted, deliberate? Was it merely bouncing light across the solar system, or was it trying to send something back? By the time autumn arrived, even the most skeptical astronomers began to hesitate before using the word comet. Every new piece of data from 3I Atlas chipped away at that label. Its unnatural stability, its metallic emissions, its reverse tail, each defied the physics that define every known object of its kind. In a live broadcast from the Royal Astronomical Society, one researcher finally said what many had been thinking for months. If this is a comet, then we have to rewrite the definition of what a comet is. The statement rippled through the scientific world. Within hours, the term technosignature, a word once confined to SETI conferences and speculative papers, began trending across professional forums and social media. If 3I Atlas truly understands how to use the sun's energy to move and reshape itself, then maybe it's not just reacting to physics at all. Maybe it's responding to something else, us. NASA officials tried to steer the conversation back toward natural explanations, but even internal discussions leaked online revealed growing unease. Archived emails and conference notes hinted that certain departments were quietly modeling scenarios outside the usual comet parameters, scenarios involving propulsion, structural reinforcement, and reflective control. Among the countless theories, two began to dominate the conversation. The first was almost poetic, that 3I Atlas was a relic, a fragment of an ancient civilization long vanished, traveling endlessly through the stars. A vessel once designed for exploration, now adrift for millennia, still carrying the fingerprints of its makers. The second was more unsettling, that it was still functioning. A probe, perhaps autonomous, crossing the solar system on a programmed course. Supporters of the second idea pointed to a subtle but consistent clue. As 3I Atlas passed near planetary orbits, it appeared to decelerate slightly, shifting speed just enough to maintain an observational angle. ESA's Mars Express logged this anomaly in October 2025, noting a fractional reduction in velocity that no gravitational interaction could fully explain. It was small, only a few feet per second, but precise. Too precise to ignore. The gas was being released in bursts, short, long, short, repeating over and over, perfectly timed. Grok mapped those pulses across time and realized they weren't random at all. Each night, telescopes tracked its path through the inner solar system. The data grew clearer, the mystery deeper, and the silence from official agencies louder. So the question remained, echoing across observatories and message boards alike. Did 3I Atlas arrive here by accident, or was it always meant to come? By late October, 3I Atlas was no longer just an astronomical curiosity. It had become a cultural fault line. The debate reached every corner of the internet, spilling out of research papers and into headlines, podcasts, and late-night talk shows. The world had split into two camps, each convinced the other was blind. On one side stood the scientists, cautious and methodical. To them, 3I Atlas was a rare but natural phenomenon, a comet-like body behaving in ways we simply didn't yet understand. They argued that strange outgassing, metallic signatures, even reverse tails could all be explained by unusual compositions or thermal dynamics from interstellar aging. To claim otherwise, they warned, was to abandon evidence for fantasy. On the other side were the SETI believers, a coalition of astronomers, engineers, and dreamers who saw something much bigger. To them, the patterns weren't coincidence. The nickel purity, the cyanide traces, the rhythmic emissions, all pointed to design. They called it a technosignature, the first in human history, the possibility that somewhere, long ago, another intelligence had built this object and sent it drifting between the stars. Public opinion fractured along the same line. Forums filled with simulations, leaked documents, and supposed decoded light patterns. Hashtags like #IsItListening and #AtlasProbe trended for weeks. News outlets invited astrophysicists and UFO researchers to share the same screen, each arguing over the same few frames of data. Behind the noise, one proposal began gaining traction. If we couldn't agree on what 3I Atlas was, we had to go to it. A group of mission planners from Caltech and the European Space Agency proposed using the Juno spacecraft currently orbiting Jupiter to attempt a trajectory shift. That idea broke everything we thought we knew about alien technology. Instead of using radio waves, this entity could be speaking through light, temperature, and molecular rhythm. The idea reignited hope, but also fear. Some warned that diverting a billion-dollar mission on uncertain data could jeopardize years of research. Others argued that missing this chance would be worse, a betrayal of everything exploration stands for. But if Get Ready truly came from 3I Atlas, it raised one question that no one could answer. Ready for what? Because once 3I Atlas leaves the sun's influence, it won't come back. And if we let it slip away, we might lose the only chance humanity has ever had to find out whether we are truly alone in the universe. For now, the mystery of 3I Atlas remains unsolved. A traveler from beyond the solar system carrying the fingerprints of both industry and biology, wrapped inside behavior no natural comet should possess. It burns with nickel instead of iron, exhales water in the frozen dark, and pulses with a rhythm that refuses to fit the laws we know. Some say it's nothing more than a rare cosmic accident, a fragment born in the chaos between stars, misunderstood by our limited eyes. Others believe it's something far more profound, a deliberate messenger, a vessel that didn't just pass by chance, but chose its path. If that's true, then the universe may have just spoken first, and what it's telling us isn't a warning, but a recognition, a signal that intelligence is not ours alone. Because if 3I Atlas is truly listening, perhaps the most unsettling question isn't what it might say, but how much it already understands. What do you think? Is 3I Atlas just an extraordinary comet, or the work of another civilization? Share your thoughts below and subscribe to MindGap so you don't miss the moment when the sky answers back.